Um, so in chapter 1, we are solving equations, right? And so I'll start by solving some equations. So example 1. Suppose we have 3x minus 8 equals to 2x plus 1. So what should we do? So we should do what? We should add 8 to both sides, right? And what else should we do? Well, we can just do that to start with. How about that? So this gives us 3x equals to 2x plus 9, right? What should we do next? Move the 2x over, right? So subtract 2x from both sides. Now, honestly, folks, like I don't usually write down. So 3 minus 2 is what? Is 1, right? So we get x equals to 9. There we go. Answer. So, to be honest, I don't typically write down these steps, right? I just think about them in my head and do it. And I think it's fine for you to do it as well. And let me show you what I mean. Like here's the same kind of example, but without all the writing. 7x plus 3 equals to, say, minus x plus 11. So I go, okay, so like you said, if I move terms from one side to the other, I change their sign, right? So if I move this to the other side, I get 7x plus x is equal to 11 minus 3, right? Which then what? We get 7 plus 1 is 8, so we get 8x equal to 8. Whoa, cool. I just made this up. Like, to get the answer being 1, that's messed up. So 8 over 8, right? So divide both sides by 8, we get x equals to 1. So in my experience teaching this class, like last time, almost none of the students have problems with these ones. Like you guys tend to like just kill these. Like these are fine. All right. So let me try to go on to the problems we tend to have more problems with. All right. So in section, these are problems from like page 45 in the text. Let's see here. So let me look at. Oh, fractions. Fractions are our nemesis. 3/4 3/4 minus 5/8 x equals to 1/2 x minus 3/8. Let's solve this. Now, here's a helpful hint. If you have fractions, you don't really want to have to add the fractions, right? Like, a nice thing to do when we have a problem like this is to try to pick the least common multiple of all the denominators and just multiply the equation by that number. Okay, so if we multiply by, let's see here, if we use 8, that will cancel everything out, right? So, so we have 8 times 3/4 minus 5/8. X is equal to 8 times 1/2 x minus 3/8. So multiplying an equation by a non-zero number is something we can do that does not change the solution set, right? Go for it.
So you're plugging in at 8, but why did we choose 8?
I'm multiplying by 8. The reason I chose 8 because it's the least common multiple. So 8 is like equal to the least common multiple of 2, the 4, and the 8. Like, it's the number that if I multiply, it's going to cancel out 2, it's going to cancel out 4, and it's going to cancel out eighths. So I'll do another example right after this one that illustrates how this works with different numbers.
Okay.
But you can multiply by anything you want. It's just 8 is nice because it kills the fractions. See, because we get 8 times 3/4, right? Minus 8 times 5/8 is equal to 8 times 1/2 minus 8 times 3/8. So this is the distributive property, right? When we have the pattern like A times B plus C, we get AB plus AC, right? This is the distributive property. It's one of the things we have to make sure we do, right? Common mistake people make is to not distribute, but just to think that that 8 just goes one place, but it doesn't. It goes 2 places when we multiply it times the sum, right? And then what happens? Well, what's 8 over 4? 8 over 4 is 2, right? So we get 2 times 3. And then here are the 8s, they just cancel, right? 8 over 8, 1. No. Haha, death to you. All right. Sorry, sometimes my math is very violent. So that gives us 5x. And on the other side, we get what? 8 over 2 is 4, right? So 4x. And then minus 3. Of course, 2 times 3 is what? It's 6, right? So I could have just written 6 here, couldn't, right? Right, now we isolate x and move the numbers to the other side, right? So I'll move the x's to the right-hand side this time. So I've got like 6 plus 3 is equal to 5x plus 4x. So again, when we move terms from the left to the right. Go on, yeah. Oh, okay. You mean with the 8 earlier? With the 8 earlier? Or? Oh, okay. Cool. So this is 9 is equal to 9x. So then divide both sides by 9. So, yeah, so I don't know. This is just my OCD. I want to write it like that, you know. Put the x on the left and then divide by 9. And that gives me, of course, x equals to 1. Now, you don't have to multiply that by a number, right? If we didn't multiply that by 8, how we would have worked that out? What would that have looked like? You know, if we had not multiplied by 8, we had 3/4 minus 5/8 x equals to 1/2 x minus 3/8, right? So we would move all the x terms to one side and move all the constant terms to the other, right? So maybe we'd have 3/4 minus 3/8 is equal to 1/2 x plus 5/8 x, yeah? But the reason that's annoying is then we got to add fractions, right? Which is the nemesis of many of our, like we have trouble adding fractions. Do you guys have calculator? So you know, either use a calculator to add the fractions, or I always work them out in my head, you know. But if you do have a calculator, it's good to check yourself on this kind of stuff. So I'll show you how I do it without a calculator. What I do is I make a common denominator. So this is really 3 times 2 over 2 times 4, right? Minus 3/8, which is, by the way, 6/8 minus 3/8, which is equal to 6 minus 3, which is 3/8. So what I'm telling you is the number on the left-hand side is simplifying to 3/8. So this is actually 3/8, right? And on the other hand, what's 1/2 plus 5/8? Well, it's equal to 4/8 plus 5/8, right? Because a half is 4/8. So the number multiplying the x is 9/8. So this right here becomes 9/8 x, right? What? Whoa. Whoa. So that, what do you do? Solve for x, right? So you have x is what? 3/8 divided by 9/8, and how does that work? That's 3 times 8 over 9 times 8, you know? The 8's cancel, you get 1/3. X equals to 1/3. Oh, this is very bad news. See, because like you may be taking other courses this semester where you can agree to disagree on the answer to a question. You know, like some people have one answer, some people have another answer. It depends on their truth. Well, math is not like that, right? We have worked the same problem and gotten 2 different answers. This cannot be. So there is a mistake in one of these solutions or the other. How can we figure out which one's got the mistake? We can recheck our steps, right? Let's see here. So I multiply by 8. 4 is 2 is 6. 8's cancel. I get minus 5x, right? 4. Got a 3, so 4x. Added the 3, added the 5. 4 plus 5 is 9. I totally agree. So check this out. I took this term, right? And I moved it to the other side of the equation, but I didn't change the sign. There it is. That's the mistake. Thank you. Oh. Let's see here. So this should have been a plus, right? Which would have made this a plus, and this would be a plus. 6 plus 3 is 9. So I should have gotten 9/8 here, which then would have given us 9/8 over 9/8, which of course is equal to 1, right? Yeah. Okay. Whew, goodness. I was worried math was broken for a second there. That's good. So, of course, I made this mistake on purpose for your learning, right? Yeah, sometimes I do that. But you're always, please interrupt me. If you see me do something like that, it is always acceptable to like interject and say, hey, hold on a second, All right, so we can solve equations like this, right? But the other thing that we sometimes need to know is like given, was it okay if I erase? Yeah. Another thing we can ask is what is a solution, right? What does it mean to have a solution to an equation, right? So let's see here. For example, we could have, let's see, you're trying to work. 9t minus 4 equals 14 plus 15t. 9t minus 4 equal to 14 plus 15t. And then the claim is, well, here's the question. Is t equals to 0 a solution? What about t equals to, I don't know, how about t equals to minus 3? Oh, by the way, this is just my shorthand. This is how I write solution, right? So to answer the question number 1, is 0 a solution? Well, if t equals to 0, right, then 9 times 0 minus 4 is equal to minus 4, but 14 plus 15 times 0 is equal to 14, which of course is not equal to minus 4, so not a solution, right? For it to be a solution, when we plug the number into the equation, it should make the equation true. So if I plug 0 in, on the one side I get minus 4, on the other side I get 14, it didn't work. It's not a solution. Right? On the other hand, if t is equal to minus 3, then 9t minus 4 is equal to 9 times minus 3 plus, minus 4, right? What's that equal to? Minus 27 minus 4. Minus 27 minus 4 is minus 31. And on the other hand, 14 plus 15t is equal to 14 plus 15 times minus 3, which is 14 minus 45, which is also equal to minus 31. So yes, t equals to minus 3 is a solution because when I plug it in, it works. So for one equation and one unknown like we're looking at today, the answer is, well, first of all, there always is an answer, unless I write a really dumb equation. Like I have to work really hard to come up with an example here which has no solution. It would have to be something extremely silly, something like Well, actually not that silly. Here's an example with no solution. Well, actually, does it have no solution? What do you guys think about this one? T plus 2 equals to t plus 3. Solve it. What's the solution? And by that I mean, are there any numbers which when you plug the number in, makes this equation true? So what happens when you move the t's to one side? You get what, like t minus t, right? Is 3 minus 2. What's that give you? T minus t is just 0, right? 3 minus 2 is what? It's 1. 0 equals 1. Ooh, that stings. So yeah, I mean, if we do allowed algebra steps, namely adding and subtracting, moving things from one side to the other, or multiplying or dividing by a non-zero number, and we arrive at an absurdity, what that means is that the original equation has no solutions. So what this shows us is, hey, no solutions. So this tells me there are no solutions. Example 6, and this will be our final example for today. I mean, up till example 1, 2, I need one more example past that. This is my next to last example. Example 6, if I had, say, 3x plus 2 equals to 3x plus 2, how about this? This is very silly in some sense, again, right? If we move all the stuff with x to one side, we get 3x minus 3x, right? So we get 3x minus 3x equals to 2 minus 2. Zero equals 0. Hey, that's true, right? What does this mean? So my point is, this is true independent of x. In other words, this equation works for any x that we choose. Try it out. Plug in 0. What happens? What happens when we plug in 0? We get 3 times 0 plus 2 is equal to 3 times 0 plus 2, right? Because 2 equals to 2. It doesn't matter what number you plug in for x. It is true, this equation. So what's the solution to this equation? Not one thing. All real numbers solve this, right? So solution. I mean, you can go on like this all day long, right? Doesn't matter what you plug in, it works, right? So solution, all real numbers. Oh, that's not a hashtag. Number. This used to be the pound symbol. Think about hashtag me too. It's really a poor choice in terms. Anyway, that's a joke for 20-year-olds more so. All right. So that's a good selection of section 1.1 problems, and next time we'll move on. So nice to meet you guys. See you Wednesday. Let me know if you have any trouble. Well, actually, don't let me know. We'll try to take the start of class next time. You guys talk amongst yourself if you got the registration working. I did post the PDF. Hopefully, if you follow that, you can get it going. But we should, at the start of class next time, make sure everyone is in the homework system and it's working, right? That is the first thing that needs to happen. So everything else is less important.